going to be on differentiation. And this is a very highly requested video. I get this request so much. So I finally decided to film it after procrastinating for so long. I hope that this video will be helpful to you. And in my log video, if you watch my logarithm video, you will know that I said that log was not difficult. It was actually simple, and it's the same for differentiation. Like, it is even more simpler than log. Okay, differentiation is a very simple concept. You just have to understand it. I know, like, it is so easy to feel intimidated by differentiation, because when I first learned it in Form 4, I was like, what the hell is this? Why do I have to learn this? But in the end, when I actually did all my revision, it was simple, and I hope that I'm going to convince you that it's simple by the end of this video. So in today's video, I'll be going over differentiation by first principle, chain rule, product rule, and quotient rule. So like the basis of differentiation before you attempt any questions related to differentiation. So if you don't know what differentiation is, I hope that I can make you understand by the end of this video. So first of all, you need to know what differentiation is and its different forms. So differentiation can come in like a few forms. So first of all, you have dy dx. So this means differentiate y with respect to x. This is the first form, and then sometimes they'll give you d over dx. This is also differentiation. And the third one is f prime x. The other form of differentiation is actually gradient. Whenever they say find the gradient, they also mean differentiation as well. First of all, we'll go to differentiation by first principle. So the first principle is when they give you a limit and the x will approach a certain value. X will approach a certain value. It's either 0, a number, or infinity. So first of all, we'll start with a number because that is the easiest. So when you're given a number, you simply sub it inside the x. So you have 3, 2 plus 1, and the answer is 7. This is the simplest form of the first principle, where you just simply sub in the value. X. Okay, now we move on to number 2, where x can approach 0. So for example, if you're given this kind of equation, then you have to be careful, because if you sub 0 into the x value, let's say you make x equals to 0, then you have to check by using your calculator if you cannot remember this, because if you take a certain value, let's say you take 9 divided by 0, it will be a maths error. There is no value for something divided by 0. This is why you cannot directly sub the value into this. But if you're taking 0 divided by something, then you'll get 0. But you cannot take anything and divide it by 0. So it is impossible that this x can be 0. So what we do is we have to factorize this. Okay, so just copy back the same thing again, but you take out the x. You factorize by seeing the denominator because you want to cut it out. So we have the x value out. So now what you do is you can cut this off and you can sub in. So when you sub in the value, you can stop writing the limit x approach to 0. When you haven't subbed in the value yet, you have to still write it. Okay, so now you sub in already. It's 2, 0, minus 1. So the answer is -1. So sometimes you have to factorize the things first before you can use the first principle, and Another case where you have to factorize, I'll show you now. There are two different cases where you have to factorize. One is when the denominator is 0, and the other one is this. Okay, in this case, it does not approach 0. The x approaches a number, and yet you have to factorize. The reason is because if you sub directly, let's say x, you use it as -5. -5 plus 5 will be 0. And you cannot divide anything by 0 because you'll get maths error, as I showed just now. So this is why you have to factorize. So you have to know immediately that x squared minus 25, you'll get x plus 5 and x minus 5 over x plus 5. So now you can cut off the similar factors. Cut off. And now that you sub in the value of x, you can stop writing the lim thing. So you'll have -5 minus 5, and the answer is -10. So these are the two different cases where you have to factorize first before subbing in the x value, and both cases are when the denominator is 0. So whenever you get something 0 and you get maths error, you know that you have to factorize. We have covered x approach 0 and x approach a number, so now we'll do when x approach infinity. So this is the example when you have x approach infinity, and if you sub directly, you get infinity over infinity. Just remember that the answer is never infinity. So if you get like infinity over infinity and you assume the answer is infinity, it is wrong. So what you do when x approach infinity is you have to divide the x by the highest power of x. Okay, so now divide everything by the highest power of x. So now x is power 1 is the highest power because there's no square here. So you have to divide everything by x. X divided by x plus 4 divided by x. This is the top part of the equation, and I'll use a red line to separate the second part of the equation. So we have x divided by x plus 3 divided, oh, it's minus 3 over x. Okay. So now you can sub x as infinity into the equation, so you don't need to write this anymore. So we have x over x plus 4 over x. When you get x over x, you immediately know that it's equals to 1, so you can just write down 1. And this one 4 over infinity, because x is actually infinity here. So when you get something over infinity, remember that it is always equals to 0. Whenever you have number over infinity equals to 0, so you can make a note here. Any number over infinity equals to 0. Okay, so you have 4 over infinity, it is 0. And then you have x over x is 1. Minus 3 over infinity is 0 again. So you get 1 over 1. So your answer is 1. I have covered this x approach 0, a number, and infinity. So we have done differentiation by first principle, so we can take that off the list. Now we'll go on to chain rule. But then before we go into chain rule, I want to make sure that you know the basis of differentiation, just a normal differentiation. So we'll just try a few questions. So if you're asked to differentiate this, then you have dy dx equals to, when you differentiate a number, it will go to 0. So you can just ignore this because it will go on to become 0. And this, it has an unknown x, so it will not become 0. So you have to take the power and times by the number in front of it. So 2 times -3, you get -6. So you write down -6, and you have to decrease this power by 0, so you get x. And your answer here is -6x. Second example, they can also ask you to differentiate from the form of fx. So maybe you have fx equals to 4x squared plus 3 over 2x minus 5. So you have to differentiate these terms one by one. Okay, so once you differentiate, it is not dy dx anymore. This is f prime x. So you write down f prime x equals, so you have to differentiate term by term. The first one, multiply the power by the number in front, so you get 8 and x. Because you have to minus the power by 1, so 2 minus 1 equals to 1, so you don't need to write it here. It's just x. And plus, okay, for this term, when the x is in the part of the denominator, it is like quite hard to differentiate, so you have to move it to the numerator. So what you do is, you change this first, 3 over 2, and you move it to the numerator. You have to write x minus 1. When you move something up, the x becomes negative, so it becomes x negative 1. Okay, now you can proceed. Take negative 1 and multiply by -3 over 2. So you have -3 over 2x. And because I said you have to minus the power by 1, so you take -1 minus 1 again, you get -2. And this is a number, so when you differentiate a number, it turns to 0, so there's no point differentiating it. So we'll move on. -3 over 2x minus 2. So to present the answer, it's best that you move the x squared down again so that there's no negative. So you move it down and you get, this is your final answer. Whenever you have something like the x as the denominator, it's best to move it to the numerator side so that it's easier to differentiate. Okay, so just keep that in mind. Now that you kind of know the basis of differentiation and how to do it and stuff, we'll actually move on to the chain rule. So number 2 is chain rule. So a chain rule is always used for a composite function. So a composite function is when you have a number in front of the equation. You have a number here. But you don't actually need to know what a composite function is. As long as you know what to do when you are given this kind of equation, is fine. Anyways, what you do is you differentiate it as any normal thing. Okay, so like previously I told you that you have to multiply the power with the number in front, so it's the same thing. You have to multiply the power by the number in front. Okay, so you have 5 times 2, 10, and you have to copy back the equation exactly. And this 5, you have to make it to 4, so here's 4. And the difference between the differentiation that we did just now and this one is just that you have to differentiate the ones inside the bracket again. Okay, so now you don't look at the outside part of it, you just look at this 1 minus 3x squared. Differentiate this again, so you get -6x. Okay, So now you can simplify this, can multiply this. So negative 60x 1 minus 3x squared 4. So this is your final answer. Now I'll give you another example of the chain rule. Another question. Y equals to 3 bracket 4 plus 5x to the power of 6. So it's the same thing again. 6 multiplied by the power. You multiply the power by the number in front. So dy dx equals to 18. And the ones in the bracket, you have to maintain it. So you have 4 plus 5x. And you have to decrease the power by 1. So here is 6. You have to minus 1, you get 5. And remember to differentiate the ones inside this bracket. Okay, so differentiate this thing. And number, it becomes 0. If you have 5x, it will become 5. So you have 5. And your final answer will be 90. 4 plus 5x to the power of 5. Okay, so these two are the example of chain rule. So we have covered chain rule. Now we'll move on to product rule. The product rule is used when there is a product of one set of equation with the other set of equation. Okay, so for example, have y equals to 1 minus 2x 4x plus 3. So something multiplied by something. So that is a formula for product rule. That's like d, dy, dx. I don't know. Maybe you've heard of it. It's a like very long formula, but you don't need to memorize that formula. What you need to remember is you need to differentiate one by one, and that's it. Differentiate this and then differentiate this. So I always like to start with the one from on the left. So we'll differentiate these first. When you differentiate these, it becomes negative 2. Okay, so because the number you can ignore and it becomes 0. So this is negative 2. And you can copy back this equation because you are differentiating this only. And you add in the middle. Now you have to differentiate the second equation. So differentiate the second equation, you get 4, and you have to copy back the first equation. Okay, so you get this. So now you just expand everything. Bring the unknowns together and the numbers together. Okay, and when it comes to the final answer, factorize the answer if you can. So what you can see is negative 2 is a common factor of these two terms. So you bring out negative 2. And this is your final answer. I'll give you another example of the product rule so you get a better idea. So you can also apply product rule to this. What you do is you have to differentiate one by one as usual. So differentiate these first. You will get 4 and bracket 3x squared. And remember that it's a plus sign in the middle, so you write this. And now you differentiate the second term here. When you differentiate 3 times x, 3 times 2, you get 6x, and copy back the thing in front, so you get this. Now what you do is you have to expand the entire equation again before you factorize again. So bring out the common factor. So as you can see here, the common factor is 6x. So you can bring out 6x and this is your final answer. Now we're done with the product rule, and I can take that off. Sometimes it's easy to get confused between the chain rule and the product rule because they are quite similar in some ways. So I'll tell you how to differentiate these two. So I'll put these two side by side so you can see the difference. When it's chain rule, you don't have unknowns here, you only have a number, okay? And the product rule is when both things here, they have x, both sides of this have x. So both has like two items, right? You have two, and then you have these, you have this, and you have this. But for product rule, both items here have x. As for the chain rule, the first item here will only have a number and not x. If it has an x, then it is product rule. The last one is the quotient rule. And this is used when there is a division of two sets of items, like two sets of equations, expressions, two sets of expressions, and you're asked to differentiate it. So I'll give you an example. So there is a formula for quotient rule. I believe it's like v du dx minus u dv dx over v squared, but you don't need to remember that formula. What you need to remember is you need to differentiate the top part first. Okay, you need to differentiate the top part of this division first, and you have to minus, because for product rule it's addition, but now you have to minus and differentiate the bottom part and over everything square. I'll just show you. Differentiate the top part first, so you'll get 2x. This one you have to copy back exactly. So 1 minus 2x. And minus, remember that's minus. Now you have to differentiate the bottom part. So once you differentiate this, you'll get negative 2 and copy back the top part. And over. So a lot of people make these mistakes of not squaring the denominator. So you just write a note here. Remember to square the denominator. Okay, so you have 1 minus 2x squared. Now you just have to expand everything and factorize again. So So this is the answer for this question. So now I'll give you another example of when to use the quotient rule and how to use it. Okay, so we'll differentiate this division. So 3 things you need to remember here. The first one is that you have to differentiate the top one before the bottom. Okay, differentiate the top one first. And the second thing is between these two things you have to write minus, subtraction, because for product rule is addition, but for this remember that it's minus. And the third thing that you have to remember is to square the bottom of the division, square the denominator. So now we'll proceed with the question. remember to square this. This is the final answer. So now we have covered the quotient rule as well. So I can tick that off the list. I hope that now you understand differentiation a little bit more than during the start of the video. If you are doing along with me, then that's really great. I hope that we achieved the aim of this video, which is to cover differentiation by first principle, chain rule, product rule, and quotient rule, which is basically 9.1 and 9.2 in the syllabus. So I really hope that this video managed to help you, and if it did help you, then remember to give this video a thumbs up, and you can subscribe down below if you want more videos like these. That's the end of this video. Thank you so much for watching, and I'll see you guys in my next one. Bye bye.